When we look up at the night skies, we witness the beauty of billions of stars.
But ever wondered how they got there? Well, let's explore the life of a star. Chapter 1.
Where do stars come from?
Our journey begins with a gas dust, or more known as interstellar dust.
It is made up of a compound of various elements such as oxygen, carbon, iron, silicon, and magnesium.
Nebulae are the general sources for these galactic dusts.
These nebulas are humongous in size and can span trillions of miles in diameter. Into perspective, the Earth's diameter is just under 8,000 miles,
while the Sun being 865,000 miles on diameter. Fun fact,
the Earth we know it was formed from the same nebula
that produced our solar system. Chapter 2. How are stars made? Stars are formed from molecular cloud, which are only a few degrees above absolute zero,
also called 0 Kelvin. When gas and dust starts to collapse within the molecular clouds, it slowly heats up.
When the collapsing region has reached
the size of nearly 10,000 astronomical units, it is called a prestellar core. This prestellar core will later become the interior core for a new star.
Over the next 50,000 years, the prestellar core begins to contract until it is around 1,000 astronomical units.
Because it is still composed of the same gas and dust, the density within the star begins to increase as the diameter shrinks to 1/10 of its original size.
After 50,000 years has passed,
the system will have formed a disk around its central core,
and excess material will be ejected outward from the poles of the star.
A pole on the star is similar to the North and South Pole on Earth, defined as the axis that the star spins around. This process flattened the disk surrounding the prestellar core.
At this point, the star is known as protostar, which means it is at its very first stage in becoming a star. The disk surrounding the protostars is crucial for developing stars. The disk is mainly composed of gas, which rotates with the disk and slowly approaches the surface of the protostar. When the gas comes close enough to the core, it collapses onto the surface of the star due to immense pressure of gravity. This process of growth is called an accretion process. Over the next 1,000 years, the matter from the disk is either accreted or expelled by the star, at which point the star has grown enough in size and density for the core to initiate a nuclear reaction. This process causes the star to shine bright like the sun. The star is now in its Tauri phase and can be observed in our night sky. The star eventually stops secreting matter from the disk, but the remaining material around the star is still in a disk-like shape.
The disk no longer serves the purpose of feeding star.
Instead, the disk is now just a circular moving plane of material which will slowly start to clump together and orbits the star.
These small clumps made from the leftover material from the star's creation will form new planets and give birth to a solar system. Chapter 3. A death of a star.
The life of a star depends on its size, as it's constantly ejecting matter.
A star like our Sun will live for about 10 billion years, while a star 20 times larger will only have a lifespan of 10 million years.
Stars always tries to be perfectly balanced, as everything should be.
The outward nuclear force is controlled by inward gravitational force, but when they exhaust their nuclear fuel, gravity wins, and the whole star will begin to collapse,
causing spectacular explosions in the universe, also known as a supernova.
The supernova will eject massive amount of materials back into space. The ending of a star will be the building blocks for a new star.
Thanks for watching.